So today we're going to cover Chapter 5, Section 5. Today we're going to learn two more shortcuts for proving two triangles are congruent. The acronyms are SSS and HL. SSS stands for side, 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 and HL stands for hypotenuse leg. So the first one is the SSS, the side, side, side. Congruence theorem, and this one states that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So what you need to do here is you need to be able to match the sides with congruency marks. Now you'll either be given the triangle with congruency marks, or you could also be given them with numbers along the sides. So let's go ahead and take a look at our markings. So notice here, AB has a single congruency mark, and it's going to match with the DE. So that could be your first congruency corresponding match. So AB is congruent to DE. And then I can look for the next one. And again, you can do this in any order. You don't have to go by the number of marks. But if I go like that mark, so here is BC with the double congruency mark. And you can see that it's congruent to EF. So BC, congruent to EF. And then lastly, we got one more match. And we can show that side AC here is going to be congruent to DF. So AC, congruent to DF. So because all three sides have a corresponding congruent match, we can come up with a congruency statement, and we could state, and the order matters here, I could state that triangle ABC is congruent to triangle DEF. Because if you notice, the first two letters I wrote here, the AB matches with the first two letters DE, and then when I went for the last two, letter 2 and 3, BC, matches with EF, same spot. And then lastly, the beginning and the end, and that was the AC and the DF. Now, you don't have to put it alphabetically. A lot of times when you see a congruency statement listed, a lot of times they might put one of the triangles alphabetically. Another congruency statement I could come up with is, let's say I went in reverse and said CBA, then I also have to reverse the letters in the FED. So when you list the final triangle congruency statement, the order of the letters matters. So last week we learned SAS, side angle side. Now today is the SSS. And then at the end of the notes, we'll also learn the hypotenuse leg. And then tomorrow we'll learn two other additional shortcuts for a total of 5. So this one, it says, decide whether the congruency statement is true and explain your reasoning. So what we need to do is match or make sure that the order of this congruency statement is correct. So the first two letters, D and F. So DF needs to match with the HJ. So what I need to do is go and look. DF or FD has the double two lines. And then HJ, that's over here, it's got the double as well. So far so good. And I could write that out. If it asks you to list the corresponding parts, this is what you would list. Then if I go to the next two, that's going to be the FG, and it's going to match with the JK. So the FG has the 3 lines, and so does the JK. So that matches as well. So I can go ahead and say FG, congruent to JK. And then lastly, I can go from the beginning to the end, the D to the G, and the H to the K. And then notice they also have the same congruency mark, just the single line. So then now I can state that as well, that DG is congruent to HK. So because all three sides have the correct corresponding congruent match in the correct order, I could say that that statement is true And my reasoning would be using the side congruency theorem. So you might be given congruency marks and look for the matches that way, or you could have numbers along the sides, and that's what we're going to see in the next example. For the next one, again, the order of the congruency statement is going to tell us what to look for. So the first two letters, AC and CA, well, technically this is the same side, and if I were writing this in a proof, it would be the reflexive property. So I can state that AC is congruent to CA. It's the same segment, and they both equal 9. Then next, I could do the next two letters, the CB and the AD. So the AD is 7, and so is the CB or BC. So I could state here that CB is congruent to AD, and they both have a length of 7. I have the last, which will be the first letter with the last letter. So I need to check AB and see if it's congruent to CD. However, AB is 3, CD is 4. These are not equal, so this statement would be false. I could not show that all three sides are congruent. So this is not true here. Same thing. It says decide whether the congruency statement is true. Explain your reasoning. So again, I got to make sure that all of the corresponding parts have the same type of congruency mark. So again, I could do the first two letters again, the QP and the RS. So if I come over here, QP has the 2 lines of congruency, and so does RS. So that one's good. So I can state that QP is congruent to RS. Let me go for the next two letters, the PT and the ST. PT has 3 congruency line marks, and so does ST. So I could also state that PT is congruent to ST. And then lastly, the beginning to the end, I can show that QT and RT, they also have the same congruency mark. So because all 3 sides have a corresponding congruent match, I can say this statement is true, and again, using side. Now, let's say instead, even though we had this same picture with the same markings, if they would have said something like, is this congruency statement true? QPT, same beginning, congruent to triangle TRS, this would be false because the corresponding sides wouldn't be in the correct order. So if they gave you something like this, again, you got to check. You can't just look and see, oh, it looks like they all have the same markings. It'll be congruent. But if they have not listed that statement correctly, then you would have to say false. So example 4, it says, explain why the bench with the diagonal support is stable while the one without the support can collapse. Well, as soon as we put in this diagonal support through here, it now creates 2 congruent triangles. And whenever you have 2 congruent triangles, this is going to create a more stable bench. So 2 congruent triangles will cause that bench to become more stable. This one over on the right could wobble back and forth. So the diagonal creates that support, which makes the 2 triangles congruent. So first we're going to talk about the parts of a right triangle. First thing you should be looking for is the right angle mark. that would indicate that this triangle is a right triangle. The next thing are going to be the names that we're going to give to the sides of the right triangle. So the two sides that form the right triangle, these are called the legs. So the legs form the right angle. The side that is across from the right angle, this is called the hypotenuse. So it's going to be opposite the right angle. And it's also the longest side. Of the triangle. Now, on the next slide, we're going to officially see the hypotenuse leg congruency theorem. The hypotenuse leg only works for right triangles. So in order to use hypotenuse leg, you're going to first have to identify that it's a right triangle and then look for the hypotenuse and one of the legs to have congruency marks. So the hypotenuse leg theorem states that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the two triangles are congruent. Notice on this shortcut, there's only 2 letters. However, we're still looking for 3 things. The first thing you need to look for is that we're dealing with a right triangle. So we need to make sure it's a right triangle. Then we'll look to see if the hypotenuses have the same congruency mark, and then one of the legs. We don't need both legs marked, just one. So let me go ahead and draw a picture to represent an example of the hypotenuse leg. So again, remember, you need to draw 2 right triangles. So it'll have a right angle. Then the hypotenuse would have the same type of congruency mark and one of the legs. Let me go ahead and add in letters. This will be A, B, C, and then D, E, F. So now, in order to show that these 2 triangles were congruent using hypotenuse leg, the first thing I need to establish is that I have right angles in the triangle. So if I show that the measure of angle B equals the measure of angle E, and they're both 90, that tells me that triangle ABC and triangle DEF are right triangles. And this would be the idea that you would establish and include in your proof. Then the next thing we would need to do is you could either state that the legs are congruent or the hypotenuse pair would be congruent. So I'll go ahead and do the hypotenuse first. I can state that AC here is congruent to DF, and this would be the hypotenuse. And then the next thing I'd have to establish is that I have a congruent leg pair. So BC congruent to EF, this is a leg. Or you could have also, if that didn't have the mark, let's say AB and DE had the mark. So you would have either needed the blue or the orange in order to establish hypotenuse leg. So you only needed one of these to establish that triangle ABC is congruent to triangle DEF by using hypotenuse leg. Okay, so here, example 5, you have a homework question just like this. I want to see you graph all 6 order pairs, and I want you to demonstrate that they are congruent or they're not congruent by finding the length of all 6 sides and show that you have the congruent corresponding matches. So let me go ahead and graph JKL. Do that one in purple. So the order pair for J is -3, -2. K is 0, -2. And L is -3, -8. Now this goes off a little bit, so I'll just put it about here. So it goes 1 square off. I'm gonna go ahead and connect it. Now what's nice about this question, notice that I've got a horizontal side of my triangle and a vertical side. So for those, I don't have to do the distance formula. I could just count the little squares. So I could see that the length of JK is 3, and the length of JL is going to be 6. However, for the length of LK, I need to do the distance formula. So let me go ahead and do that. So for LK, the order pair for L is -3, -8. For K, 0, -2. Remember the distance formula. We subtract the x's, square them, subtract the y's, square them, and then add those two sums. So 0 minus -3 squared plus -2 minus -8 squared, all under the radical. This turns into 0 plus 3. This turns into -2 plus 8, all under the radical still. 3 squared, 6 squared, 9 plus 36 gives me 45. Break it down. 9 and 5, 3 square root 5. So the length of LK is 3 times the square root of 5. Now I need to go back and graph RST. So for RST, I'll do that one in red. R is the order pair 10, 0. S, 10, -3. And T, 4, 0. Go ahead and connect them. So now I can see RS is going to be 3. I can count the squares. You can do the distance formula as well. And then 6. And now let me go ahead and show the work for ST. Now you're already going to see that it's probably going to be the same, but I still want to see the work. Practice the distance formula. So 10, -3, 4, 0. Subtract your x's, square it. Subtract your y's, square it, all under the radical. -6 squared, and this turns into 0 plus 3, so 3 squared. 36 plus 9, 45, 3 radical 5. So now, I'm going to show the corresponding congruent matches. So I could show that JK is going to be congruent to RS. And then I can show the JL congruent, that's the side that has a length of 6, to the RT. And then lastly, I can show the KL, or the LK, congruent to the ST. So I've got all the congruent corresponding matches. So my congruency statement could be that triangle JKL is congruent to triangle RST by using side, side, side. Now, technically, because I've got horizontal and a vertical line intersecting, I know that a horizontal and a vertical line always form perpendicular lines. So I also could show I've got a right angle here. So I could also have shown side angle side. Now, if you weren't graphing it and you didn't see that it was horizontal and vertical, then what you would have had to have done is calculated the slopes of the lines and shown that they were opposite reciprocals. So that would have been the justification for side angle side or even hypotenuse leg. So this one you could have either used side, 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 side angle side, or hypotenuse leg, depending on the calculations you did for the problem. So in the homework tonight, when you get to this question, I want to see you graph them. I want to see you do the distance formula for any of the sides that are diagonal. And if you choose to use something other than side, 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 then you would actually have to do the slope formula to show if they're actually perpendicular, that they're perpendicular and they're forming right angles. All right, so for this one, is there enough given information to prove the triangles are congruent? If there is, state the postulate or theorem. Now, I know it's kind of hard to see, but right here it shows, and it's like in white writing, F, G, H, and then there have this one, and this one says H, J, K. So they've given us the order that they want it. So let's go ahead and see if we can make these corresponding matches. Now, notice I've got right angles. So what I can do here is look to see if I could use hypotenuse leg. So let's see if the hypotenuses have the right mark. Well, this is opposite the right angle, and it's got congruency marks. And notice HF is going to be the first two, and it matches with the HK. And then let's go back and look at the marking on the leg. So that's the GH. GH is these two, and it matches with the JK. So I've got a leg that's marked and the hypotenuse. And I've got a right angle. So yes, I could state that these two triangles are congruent by using hypotenuse leg because it's got the right angle and it's got the legs with a congruency mark and the two hypotenuses. And the last example is a proof. So it wants us to write a proof. Now, in the homework where it's going to ask you maybe to write a proof, it may ask you to pull the picture apart. And that's what I've done here. So what they're asking me to try to prove is that this triangle, the WYZ, is congruent, so it's this one right here, to the XZY, which is over here. So let's go ahead and start filling in what they've given to us. So number one, WY congruent to XZ, WZ perpendicular to ZY, and XY perpendicular to ZY. So the first thing I can do is, because I've got some perpendicular lines, I can see that I've formed some right angles. So, and they've added that to the picture already. I've got a right angle right here and here. And that would have been also right here and here. So that's what's going to be my next statement, is that angle Z and angle Y are right angles. Now, if you did not pull the two pictures apart like this, you would have needed to name angle Z with 3 letters. So if you didn't pull it apart and you left it like this, you would have had to tell me that this angle Z was actually WZY, and the angle Y was angle XYZ. So if you don't pull it apart, then you're going to have to name it with 3 letters. So number 1 was given. Number 2, the reason why I can state that these are right angles is because the definition of perpendicular, or definition of perpendicular lines. The next thing I have to establish is that these 2 triangles are right triangles. So triangle WYZ and triangle XZY are right triangles because they have right angles. And this is definition of a right triangle. Now what I need to do is go back and look to see if I've got a hypotenuse that's marked and a leg. Well, they gave me the hypotenuse being marked from the beginning, and you can see the little markings here. I sort of highlighted over them. So I already have the hypotenuses. They've got the congruency mark. Now I just have to come up with the leg. And if you notice, this bottom of the triangle here, ZY, it's the same in both triangles. So I can say that ZY is congruent to either ZY, or I could reverse it the way it's listed. I could say that ZY is congruent to YZ, or you could also say ZY, doesn't matter, and this is reflexive because it's the same side. And now lastly, because now I've labeled the right angle, the hypotenuse, and the legs, I can state that triangle WYZ is congruent to triangle XZY by hypotenuse leg.